Alright, for this next video we're going to be looking at how to work with some polynomials, just plugging numbers in and evaluating them. We have done some of this earlier in the semester, but now we're going to do this with a little bit different notation. When we looked at these before, earlier in the semester, we might say something like evaluate, I'll do like 3x squared minus 8x plus 7 for x equal -2. And so then we just plug that -2 in for the x's. We'd have 3 times -2 squared minus 8 times -2 plus 7, so all the x's became -2, and then we use the order of operations to simplify. So we do the exponent first, that'd be 3 times 4. -8 and -2 makes a positive 16. And then we multiply the 3 and the 4 here, that's a 12. Now I know I did two operations in the same step here, but because they're separated on different terms, they won't interact with each other, and that's actually not a bad thing. It can be done. Then we can add 12 and 16, we get 28, and then add the 7, you get 35. Okay, and now that is it's nice. It's not very difficult really, and the notation is nice. However, there is a new notation we're going to introduce that's just going to make things a little bit more organized for us, and it's called function notation. We're going to distinguish between two types of numbers here. One are called the inputs, and the other is called the outputs. Okay, inputs and outputs. In this previous example, the input was -2. It's the number you plug in to the polynomial. The output was the number 35. It's the number that came out of the polynomial. Okay. The input is what you plug in, the output is what you get out from that after you've evaluated. Okay. Now function notation wraps all the stuff in kind of a nice tidy notation. Function notation, what we're going to do is we're going to often use the letter F to represent a function. And in parentheses we're going to put an x. Now we notice up here the x was the thing we plugged in, right? X equals -2, that's what we plugged in. So the thing in parentheses is the thing we're plugging in. So here the x is the input, the f of x, this notation is going to be the output. So if f of x equals 3x squared minus 8x plus 7, then f of -2, notice my input is -2, is going to be the same as what we got when we plugged in the -2 before. So we'd have 3 times -2 squared minus 8 times -2 plus 7. We would evaluate that, which I already did, so I won't go through all the work, and you get 35. Okay. So the number in the parentheses is considered the input. The number out of the parentheses is considered the output. Okay. Let's do a couple more examples so you can just see. But really all we're doing is evaluating the polynomial. Alright, so let's try one. And we can also change up the notation here with the letters. We could say something like, g of a is equal to 5a to the third minus 2a squared plus 4. Alright, so here I have a new function, a new polynomial. I'm using a instead of x, but it doesn't matter what the letter is. And then let's say I wanted to find g of 3. Well, then I just take that 3 and plug it in for all the a's. So I'd have 5 times 3 to the third minus 2 times 3 squared plus 4. Just simplify this. So 3 to the third is 27. 3 squared is 9. 5 times 27 is 135, I believe. Just double checking that. Yep, 135. 2 times 9 is 18. 135 minus 18 is, should be 117. Yeah, 117. And add 4, you should get 121. Okay. So g of 3 is equal to 121. The input again is the 3. Let me write that out. The input is the 3 because that's what's in the parentheses. The output is the 121. That's what's coming out of the parentheses. Okay, so you've got the input and the output ideas. Okay, now you could get a little bit more complicated with these, and you could have inputs that are new variables or new expressions. So let's do something like p. Let's go with a p for polynomial. P of x equals, let's do 5x squared minus 18x plus 3. And let's find p of, let's do p of z. Well, then p of z, all you do is replace all the x's with the z. The input is z now. So you get 5 times z squared minus 18z plus 3, and that's it. There's no simplifying involved. It's just that simple. Let's say I also wanted to change this up and compute p of x plus 2. Now I'm going to use an entire expression. Well, p of x plus 2, now this is maybe a bad example, but it would be 5 times, now the x becomes x plus 2 squared minus 18 times this x also becomes x plus 2 plus 3. Now that's a bigger expression than we can really deal with right now because we haven't learned how to square some of these things and expand this. So we'll say all this can be simplified in a later section. So simplified in a later section. It's okay to do this now because the ones in this section aren't going to be that complicated. Let me try another example where a little bit more on line with the difficulty you'll see. Let's do something like f of x equals 8x minus 6. Right? And then we could find f of x minus 5. Right? So to do that, you would replace the x with the new input, which is x minus 5. So you'd have 8, and then instead of this x, you'd have x minus 5, and then subtract the 6. Notice how the x becomes x minus 5. Then you can distribute and simplify. So you get 8x minus 40 minus 6, which is just 8x minus 46. Okay. So here, in this example, the input would have been x minus 5, and the output